Hello class, so welcome to this 1.3 homework video. We're going to go ahead and get started. This lesson is about partitioning midpoints and distance. So looking at the first question here, we want to find the coordinates of the point 3/10 of the way from A to B. This is from the online Savas homework. Remember that the Savas homework randomly generates problems. It'll randomly change some of the numbers around, maybe the coordinates or the fraction that's used here. So it might not be exactly the way the homework problem that you were using, but it's the same type of problem. So the first question asks us to find is a partitioning problem. So the coordinates of the point 3/10 of the way from A to B. So first off, what you want to do, you want to actually find the horizontal component and the vertical component of this line segment. So we call those the horizontal and vertical distance. So remember, to do that, for the horizontal distance, I subtract the x coordinates for that. So for the horizontal distance, I simply subtract the x coordinates under an absolute value. So 9 minus -4. Becomes a double negative, becomes a positive. So this is really 9 plus 4, which is 13. And we know that the absolute value of 13 is 13. That's my horizontal distance. So next we want to figure out, we want to actually find our vertical distance right here. Yeah, I'll use another color here. And to do that vertical distance, you subtract the y coordinates. So in this example, we have 6 minus -8. Remember, under an absolute value. And then a double negative turns into a positive, and 6 plus 8 is 14. So we got our vertical distance and our horizontal distance, and I'll go ahead and label them here. So next we want to figure out our vertical and horizontal change. Okay, so our vertical change is our horizontal change is our horizontal distance times the fraction of the way that we want to get to. So we want to get to it 3/10 of the way. So we want to figure out what 3/10 of 13 is. Remember that when you multiply by a whole number, make sure to put that over 1 and multiply straight across here. So we have 13 times 3, that's 39, and then 1 times 10 is 10. So this horizontal change here is 3.9. So now we want to do our vertical change, which is going to be the 14 that we got earlier, times the fraction 3/10. Remember, put this over 1 and then multiply straight across. So 14 times 3, that's 42 over 10. So this is 4.2. So we got our horizontal change, we got our vertical change. So this means that we're going to go from our starting point, and I'll go ahead and erase this now. So from our starting point A, we want to go over to the right by 3.9. And that means we're going to add 3.9 because we're going to the right. If you're going to the right, then that's a positive, right? So we're going to go to the right by positive 3.9, and we're going to go up by positive 4.2. Up means positive. And so what we're going to do is we're going to add the 3.9 to the x coordinate, and we're going to add the 4.2 to the y coordinate, and that's going to give us our new coordinate, which we'll call xy. Okay, so to get the new x coordinate, we have to take the old x coordinate, which is -4. Remember, we know that A is our starting point because we're starting from A to B. So our old x coordinate is -4 for A, right there. And we're going to add to that my horizontal change, which is 3.9. And then we get -0.1. And then for my y coordinate, we're going to use the y coordinate for our starting point, which is -8. And we're going to add 4.2 since we're going up. Remember, we want to go towards the line segment, not away from it, okay? So then this is going to be -3.8. And then we're going to put this into a coordinate. So we have -0.1, -3.8. Remember that x goes first and then y when you lump it into a coordinate. And that's your ordered pair for your final answer. Okay, so that takes care of that question. The next question we're looking at is just, correcting an error that a student makes. So we're trying to figure out, well, the student is is calculating the midpoint. And so this is the student's work right here. And so we want to figure out, well, what's the error that the student makes? Well, remember that to calculate the midpoint, the formula for the midpoint is you have to add the x coordinates together and divide by 2. Then you have to add the y coordinates together, divide that by 2. So that's the formula for the midpoint. So let's call this x1, let's call this x2. Well, then this has to be y1, and then this has to be y2. So -4 is x1, and 5 is y1, and -1 is x2, and -4 is y2. So then if we put this into the formula, right? Well, we're going to add the x coordinates together. So -4 plus -1 divided by 2. And then now we're going to add the y coordinates. So 5 plus -4 divided by 2. And so now you can see that the error involves that minus sign, right? So they subtracted instead of added, right? And in the formula here, we added, we would add, not subtract. Okay, so that seems to be the mistake there. So if we look at the answer choice, does the student swap the x and y values? No, that's not true. Student used incorrect coordinates? No, that's not true. Student did not divide by 2? No, they did divide by 2. The student did not add the x and y coordinates, and so this is what we're looking for. And so if we want to figure out the final answer, well, -4 plus -1, that's -5. And 5 plus -4, that's 1. And so this should be my midpoint for the final answer instead of this. Okay, so now let's look at the next question. So the next question is another midpoint problem. And this time they're asking, can the value of A be determined? So this is the diagram, and we want to figure out what A is. And so they want to figure out, well, how do we figure this out if we have two unknowns, essentially? We have A and B. We don't know what they are. We only have, expressions. So remember, to find the midpoint, we add the x coordinates together, divide by 2. We add the y coordinates together, divide by 2, right? So that's exactly what we're going to do here. So we know that to find the midpoint, we need to add the x coordinates. Well, this is x, remember, then this is x, this is y, and this is y, right? Traditionally. So we're going to add those two x coordinates together first. So we have 2a, that's my first x coordinate, plus my next x coordinate is b plus 1. Divide that by 2. That takes care of the first one. Now we're going to do the y's. So the first y is 3b plus 3. My next y is a plus 2. I'm going to divide that by 2. All right, so there's our formula, right? We added the x's together. This is x1 plus x2, divide that by 2. y1 plus y2 divided by 2. That's the formula. So now we're going to actually figure out what this is. So first off, we know that the midpoint is actually 3, 5, right? So that means, what that's saying is that since we know that this is x and this is y, well, that's saying that this coordinate, this right here, this equation that we have here is actually equal to 3. And this one is actually equal to 5, because if we compare those directly to this, well, the first coordinate has to be 3, the second coordinate has to be 5, right? So really, we have two equations here. We have, and we'll write those equations. So equation 1, we have that the 2a plus b plus 1 over 2, all that stuff is equal to 3. That's this first part. And then equation 2 is the second part. So we have 3b plus 3 plus a plus 2, all divided by 2. That whole thing, that whole mess, and that has to equal 5. And so those are our two equations. So we have two equations and two unknowns. What do we call such an item? Like, what is this called? Well, this is called a system of equations, right? A system of equations involves two or more equations with two or more unknowns. So that's really what we're looking at here is we have a system of equations. So if we look at here, to determine the value of a, you set the x and y coordinates of f and g and f equal to each other and solve for a. No, that's not true. That's not what we did. To determine a, set up and solve a system of equations. That's exactly what we did. So that is correct. We set up and solve a system of equations. And so that's what we're going to actually find. So we want to figure out the value of a, okay? So according to this thing, we want to figure out a, and we might as well find b as well. So we're going to solve this system of equations here. So you may remember how to do this, you may not. So let's go ahead and review how to actually do something like this. So first off, we have 2a plus b plus 1 divided by 2 equals 3. So first off, we want to get rid of this 2. So what I'm going to do is I'm going to multiply both sides by 2, and that'll get rid of it, okay? So now this cancels, and so this goes away. I can do that. I can get rid of that as long as I multiply on the other side too. And then we know 3 times 2 is 6. So I'm going to change that to a 6. And that's my first equation. And for my second equation, I'm going to do the same thing. I'm going to times this by 2, okay? And then do the same thing here, times that by 2. Then if I do that, this goes away in the bottom. And then 5 times 2 is now going to be 10, right? So let's go ahead and change that. 3b plus 3 plus a plus 2 equals 10. That's my new system of equations. We're going to use that because that's easier to use. And so now we have, well, let's move this 1 over to the other side. And so we have 2a plus b equals 5. That looks easier. Let's combine the 3 and the 2 here. The 3 and the 2, that makes 5, right? So let's change this to a 5. 3 plus 2 is 5. And just kind of sandwich the a in the middle. All right, let's now get rid of this plus 5 by subtracting it on both sides. And so now we get 3b plus a equals 5. Okay, so we got here these two equations. And so now what we want to do, we want to actually solve them. So let's go ahead and solve for a. Let's solve for a in here. So if we solve for a, we're going to have to subtract 3b on both sides. And so a is equal to 5 minus 3b. So this, what we just did is we solved for a, and then we're going to take that and we're going to plug for a in here. And that's called substitution. You guys may remember this from Algebra 1. This is called the substitution method, where we solve for a variable and then we substitute it. Okay, so if not, then if you don't remember that, well, I'm showing you the process. You solve for a variable and then you plug in, okay? And so now we're going to actually plug in. So we have 2 times a, but what is a? Well, a is all of that. Okay, so we have 2 times a, and a is now 5 minus 3b. So we replace that. And then we have plus b equals 5. Let's go ahead and solve this real quick. So we have the distributive property. Remember, 2 times 5. And then 2 times 3 is going to be minus 6b. Plus b equals 5. We're almost done solving for the variable. Let's go ahead and do it. Negative 6b plus b, that's negative 5b. All right, we'll subtract 10 on both sides. Let's finish this up quickly. And then so divide by negative 5. So then b has to be 1. Okay, so b is 1. Finally, we got b. So then we can plug b in here and get a. So we have a equals 5 minus 3 times, and b is now 1. So 3 times 1 is 3, and then we have 5 minus 3, which is 2. So a is equal to 2. So that's how we get a and b for this problem. All right, so that one was a review of Algebra 1 and also just the midpoint in general. So that one was a tougher problem for sure, which is why I wanted to cover it. So now this one is another midpoint. The coordinates of point T are 0, 3. The midpoint of ST is 5, negative 6. Now find the coordinates of a point S. So they're saying that there's a T, there's an S somewhere, right? We know the coordinates of T. We know the coordinates of the midpoint, which we'll call M. but we don't know the coordinates of S. They're a question mark, okay? So we don't know what they are. So this time instead of finding the midpoint, we're finding one of the corners, right? So how do we do that? So let's go ahead and use the formula. Remember that the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? So let's just call this x1 and y1, okay? And we'll call this we'll just call this x2 and y2 because we don't know what they are, right? So we'll call those x2 and y2. So we don't know those, but we do know x1 and y1. So let's plug that in. So this is now going to be 0. Y1 is now going to be 3. Okay, so let's replace those right now since we know what they are here. So 3 and 0. Okay. And so what do we know that this equals to? Well, we know that this equals to 5, right? Because this is the midpoint formula. It has to equal the midpoint, right? And we know that this is equal to -6. Okay, so we're going to go ahead and plug that in. And we're going to say, okay, well, this is equal to 5. So let's go ahead and write that equation. 0 plus x2 divided by 2 equals 5. And then we know that this has to equal -6. So we have, well, 3 plus y2 divided by 2 equals -6. And those are my two equations, and we can solve those easily. Remember that 0 plus anything, 0 doesn't do anything, so we can get rid of it. And now we can get rid of this 2 by multiplying by 2 on both sides. And now we know what x2 is. x2 is 10. All right, and for this one, we can get rid of the 2 by multiplying by 2 on both sides, just like we did before. And that's going to be 3 plus y2 equals -12. Then we'll subtract 3 on both sides, and we'll get our y coordinate. Just like that. And so my coordinates are 10 and -15. And that's how you use the midpoint formula to kind of go backwards and solve for one of the other unknowns. All right, so that's a more difficult midpoint kind of question. So now let's look at another question. The endpoints of RS are those two, -5, 4, and 11, 16. Complete each statement using a fraction. So for part A, -1, 7 is the point blank of the way from R to S. So they want a fraction here. Okay, so they want to figure out, is it 7/10 of the way? Is it 5/10 of the way? Is it 3/8 of the way? How far of the way is it from R to S? And so what we want to do, well, in order to do this, well, we had to figure out, well, how far is it from there to there? That's really what we want to do. So pick one of the distances that you want to do. So let's pick X, okay? How far is it from -5 to 11? Well, okay, so so that's the horizontal distance, right? So the horizontal distance is absolute value 11 minus -5. Okay, so remember we subtract those coordinates and then we put an absolute value. Well, a double negative is a positive. So we have 11 plus 5, that's 16. So it's 16 of the way from -5 to 11. So let's make that our denominator. We know that that has to be our denominator. The denominator has to be the total distance, right? And now we're going from R to S. So we want to figure out, well, what's the numerator is going to be related to R. So how far is it from the R, the X coordinate of the R, which is the -5, how far is it from there to the X coordinate that we're interested in? So in order to do that, we need to actually subtract that, right? So we got to go -5 minus -1. So we subtract those two distances together under an absolute value. And then this double negative becomes a positive. -5 plus 1 is -4. And then absolute value of 4 is 4. Okay, so then that's how far it is from this point to R when you're talking about the X's, okay? And so that's going to be 4. So it's 4/16 of the way from that point to R. And so that means that the fraction is 4/16, but we can reduce that fraction, and by dividing by 4, we can reduce it to 1/4. Okay, so it's 1/4 of the distance from R to S. And you can do this for the Y's as well. So if you did the Y's with the vertical distance, you're going to get the same answer, the same final answer if you did it for the Y's separately. So just choose whether you're going to do it for X's or for Y's, but don't do it for both. That would be too much work, right? So just pick one of them and then get the fractional distance from one to the other. Now this time, just to kind of show you, for part B, we're going to use the Y distance now, okay, instead. So this time, instead of using the horizontal distance, let's use the vertical distance. So we'll use 4 and 16 for this example. So like I said, I'm just doing this so that I can show you that you can use the Y's. So remember, the vertical distance from 4 to 16, you just have to subtract them, right? So it's going to be 16 minus 4, absolute value, which is just 12. So the vertical distance is 12. So now we get to figure out, well, what is the distance from this point, the Y coordinate of that point, because now we're dealing with Y's, the Y coordinate of that point to the Y point coordinate of R. So we're looking at between these two, right? So we're going to figure out the distance between those two. So that's going to be absolute value of 13 minus 4. Doesn't matter what order you subtract it, by the way, because it's absolute value. So you're going to get 9. So the total distance is 12, and the original distance is 9. So, or the distance from R. And so you can reduce this fraction, divide by 3, and you're going to get 3/4. Again, if you did this with the horizontal distance for part B, you're going to get the same exact answer of 3/4, okay? All right, so that's how you do the fractional distance for partitions. So the next problem, we want to find the midpoint of the line segment. So you're just using the midpoint formula, nothing more, less here. So again, it's really straightforward. You add the x coordinates together, 4 plus 2, then divide by 2. Then you add the y coordinates together, divide that by 2, and that'll give you the midpoint. And so our midpoint here is, so 4 plus 2 is 6, 6 divided by 2, well, that's just 3, right? And then negative 5 plus 1 is negative 4, then over 2. Negative 4 divided by 2, that's just going to be negative 2, right? So let me just show my work here. And that's my final answer. So it's just 3 negative 2. All right, look at the next question. So point B is 1/6 of the way from A to C. What are the coordinates of C? So this is kind of like the other problem that we did earlier. You're going to find the horizontal distance first. So we do that by subtracting the x's. So 12 minus negative 3, absolute value, double negative is a positive. 12 plus 3 is 15. Now let's do the vertical. Again, you subtract the y's. So we have absolute value, 5 minus negative 7. Double negative is a positive. 5 plus 7 is 12. Then we multiply those, and I'm just going to do that right here. Let's multiply those by 1, the fraction that they gave us, 1/6. Put this over 1. Let's do that here as well. So 15 times 1 is 15, 1 times 6 is 6, and then 12 times 1 is 12, 1 times 6 is 6, 12 divided by 6 is actually 2, so this actually works out very nicely. And then 15 divided by 6, so that reduces, we can divide this by 3, so that's going to be 5 over 2, so this is 2.5 on the calculator. All right, so we have 2 and 2.5, so that's saying, and remember, we're going from A to C, so we're going from A, so that means we're going to go to the right, which means we're going to add the horizontal distance. This is the horizontal change. And then we're going to go up to get to the line segment. We're going to go up by 2. So up means you're going to add. So we're going to add 2. What are we going to add that to? Well, we're going to add that to the original, to the x and to the y. So x equals original x of negative 3 plus 2.5. Y equals original y for A, so negative 7 plus, and then we're going to add the 2 that we got here. And so negative 3 plus 2.5, that's negative 0.5. And then negative 7 plus 2 is negative 5. So then you're going to put those in a coordinate, so it's negative 0.5 and negative 5. All right, and that's how you do the ordered pair for this is a partitioning problem. Okay, so let's look at the next problem. So this is looks like a distance formula. Use the map shown to find the distance between two cities A and B to the nearest 10th. So we're going to figure out the length of that line segment. So what are the coordinates of B? The coordinates of B are -4 and 4. Coordinates of A are, A is just 0, 0. A is literally right in the middle at the origin. And so we're going to be doing the distance formula. Remember the distance formula, I'll write it down, is x2 minus x1 squared plus y2 minus y1 squared. So you just plug it in. We'll call this x2, y2. We'll call this x1, y1. Does it matter which one you call x2, y2, x1, y1? The answer to that is no. As long as you are consistent. So remember, x has to be the first coordinate, y has to be the second coordinate. That's just the way it works, okay? So we have the square root. X2 is -4 minus x1 is 0, so squared. Y2 is 4, y1 is 0, and then square it. So we have square root. So we have -4 minus 0 is -4. We got to square it. 4 minus 0 is 4. We got to square that. So -4 squared. -4 times -4. That's 16. 4 squared. That's 4 times 4. That's 16. We add those together, we get 32. And then, so that's my answer. We're going to do that on the calculator. So the square root, so I just did it on this calculator here. But if you did it on the calculator, you type that in, you're going to get 5.66. And they want it to the nearest 10th, right? So that means we're going to round this up to 5.7 for my final answer. So it's 5.7 miles or units, whatever, from A to B in this example. All right, so this looks like another distance formula just by looking at it. On a zipline course, you're harnessed to a cable that travels through the treetops. So there's a bunch of cables. You start at platform A, start here, and you zip to each of the other platforms. How far do you travel from platform B to platform C? So we're interested in that part. And so all we got to do is figure, that's another distance formula. So the coordinates of B are negative, right here, -25, and looks like -15. The coordinates of C looks like -15 and 10, right? So the coordinates are there, -15, 10. And so, okay, well, let's call, so this is x, this is x, this is y, this is y. We'll call this x1, y1. We'll call this x2, y2. All right, so it doesn't matter which one's 1, which one's 2, just as long as you're consistent with x, y. So the distance from B to C is equal to the square root. Now you're going to subtract the x's. So -15 minus -25 squared, x1, x2 minus x1, that's the formula, squared, plus, and then y2 minus y1 squared, y2 minus y1, then squared. And then we'll do the math here. So this is a double negative, so that's a positive. -15 plus 25 is 10. So we have 10 squared there. Double negative, 10 plus 15 is 25. So we have 25 squared. So 10 squared, 10 times 10 is 100. 25 times 25 is 625. You could do that on the calculator. Just do 25 squared. And add those, you get 725. And so they want us to round it to the nearest 10th. So we'll do this on the calculator. So then we'll have 26.9 because we're going to round it to the nearest 10th. So 26.9 meters. All right, on the graph, plot a point that divides the segment into the ratio AC to AB equals 3/4. So all we're going to do is we're just literally plotting a point. So we can ignore this. That's not part of the graph. So this is the graph, the line segment. Okay, so if the ratio AC to AB is 3/4. Okay, so that means that So let's just say C is somewhere there. We don't know where it is right now. But they're saying that the ratio from there to the whole thing is 3/4, just like that, right? And so really they're saying that the whole thing is equal to 4. And so they're saying that there are 4 pieces to this line segment. So we got to break this line segment into 4 pieces is what they're saying. So, okay, so that means we got to slice it 3 ways, right? So let's try to do the best we can here. So let's say 1, 2, 3. That looks to be 4 slices or 4 pieces, right? Slice 3, I sliced it 3 ways, so there's 4 pieces. And then you want to go from A to C, wherever C is. And we want it to be 3 pieces away from A, right? So 1, 2, and 3. So it looks like the point C has to be here so that there's 3 spaces there and 4 for the whole thing. Okay? So that looks to be the coordinate. That looks to be right. And so the coordinates of that are 4, 4. So we have our coordinate. So that's it. Plot a point. So that's our point. All right, guys, that's it for the homework problems. I hope you found this useful, and I'll see you in the next one.